I'm going to have another formula to learn. This is for arithmetic series. Arithmetic series is formed when you add up the terms of an arithmetic sequence. And the notation they use is SN. Okay, so SN is the sum of the first terms of an arithmetic sequence. So before I show you the formula, I'll do an example. Prove that the sum of the first 100 natural numbers is 5050. Okay, so the natural numbers are just the positive whole numbers. So they're talking about 1 plus 2 plus 3 plus 4 up to the first 100 terms. Okay, so you want to calculate that sum, obviously not by doing it individually, that's a crazy way to do it. So the notation would be S subscript 100. Okay, so this is an arithmetic series. It goes up by 1 each time. First term is 1 as well. So to calculate that sum, there's a clever way to do it. Clever method. You write out this series backwards. So I'm going to reverse it. If you reverse it, write out backwards. Okay, so I'm going to start with 100 plus 99 plus 98, etc. all the way down to 3 plus 2 plus 1. So that's the same series written backwards. Okay, the next trick, you add up both expressions. So when you add, on the left-hand side, if you add these together, you get double the sum. So on the left, you'll get 2 times sum of the first 100 terms. Okay, this is the clever bit. If you match up these together, if you add these together, that will give you 101. If you match these together, that will also give you 101. And if you just carry on, you'll get 101 appearing all the way to the end. 101, 101, 101. Okay, so the question is, how many pairs of 101 do you have? Well, the series had 100 terms. So that means you have 100 lots of 100 pairs of 101s. Like that. Any questions on what I just did? Was that too clever? Okay, then final step, you divide everything by 2. So I can now say the sum to 100 terms. So the sum of my series then is 100 times, so this is a calculation you can do, 100 times 101 divided by 2. So that's a calculation you can simply do. If you work it out on a calculator, 5050. So I just proved that the sum of the first 100 terms, 1 plus 2 plus 3 up to 100, is equal to 5050. Okay, things to notice about my final calculation. Okay, so this here, this 100 is from the number of terms. The 2 on the bottom is always there. It's just part of the whole process because I'm adding the 2 series together. The 101 I get by adding together the first and the last term. So basically, it's 1 and 100. So it's the first plus the last term. So you can think of it as A plus L, where L is the last term. Okay, so if you have an arithmetic series and you know the first and last term and you know the number of terms, you actually have a formula for calculating it. N over 2 first plus last. So there's a more general formula which I'm going to show you now. And you have to learn how to prove this formula as well. So this is the general formula for any arithmetic series. So this is the general formula for working out the sum of any arithmetic series. You just need to know what n is, you need to know what the first term a is, and you need to know what the common difference d is. Okay. From that, you can actually get this other version of the formula if you know the last term. So you need to learn the proof. So I'll go through the proof of that formula. Proof. Okay, so the proof of the formula is basically the same technique as I showed you above. You write out the series, then you write it out backwards. Okay, so you begin by saying the sum to n terms. So the first term is a. The second term, you add the common difference d. That's the second term. Then you add on the third term, a plus 2d. Carry on up to the nth term. So the one before it would be a plus n minus 2d. And the nth term is a plus n minus 1d. So this is un. So I've written out the series forwards. Then the next trick, you write it out backwards. So you reverse the series. So you start off with the nth term. Okay, the one before it would be a plus n minus 2d. Carry on writing that backwards. So you will finish off with a plus 2d, a plus d, and the first term. Okay, so I've written out my series forwards and backwards. Next step is to add the two series together, and the miracle will happen. So the next step, you add the two series together. So when you add these together, you get twice the sum. So you get 2Sn. So you end up getting 2 lots of Sn. Okay, and the clever bit, when you add these together, pair them up again. If you pair this together, you'll get a plus a gives you 2a. So you end up getting 2a plus n minus 1d. So this is the expression which is going to be repeated. If you add the next pair together, a plus a gives you 2a, n minus 2d plus 1d will give you n minus 1d again. So that expression is repeated. So if you go all the way through to the end, that pair will give you 2a plus n minus 1d. Okay. So if you pair them up, you get the same expression, 2a plus n minus 1d, just repeated throughout. The question is, how many of these pairs do you have? Well, I'm adding together n terms. So I just have n lots of the expression. Then the final step, to find Sn, you just divide everything by 2. So when you divide by 2, you get n over 2 bracket 2a plus n minus 1d. So that completes the proof for the sum formula. Okay, so you need to learn that proof, and you need to learn all the steps with the same amount of detail. As a side step, you can also get the other version of the formula with the a and the l. So you can also write this as n over 2. You separate it as a plus, split up the 2a. Now this last term here over here is the last term. That's the nth term. In other words, that's the last term of the series. So you actually get the other version of the formula, n over 2, a plus l. That's okay if you know the last term. If you don't know the last term, you just need to substitute n, a, and d. So I'll do a couple of examples to show you how to apply that formula. It's just substituting numbers. Okay, find the sum of the first 50 terms of the arithmetic series. Okay, so this is an arithmetic series. Goes up, what is that? Goes down by, going down, okay. A is 5. D is going down by 5. So D is minus 5. N is 50 terms. So I'm summing the first 50 terms of that series. So if you want the notation, S50. Okay, so according to the formula, it's n over 2, 2a plus n minus 1d. So you just plug in the numbers, 50 terms required over 2. 2 times the first term, a is 32. Sorry. First term is 32. Okay, so a is 32, d is minus 5, so it's going to be 2 times 32 plus n terms, n is 50, so you need to substitute 50 into here, multiplied by minus 5. It's going down by 5 each time. So that calculation will give you the sum of the first 50 terms of that series. It's going down, so eventually it becomes negative. Eventually it will become very negative. 4525 is the sum of that series. The other one they have, okay, slightly different one. I don't like what they've done in the book. Find the least number of terms required for the sum to exceed 2000. So you want to know when this sum goes beyond 2000. So the question is asking you to solve Sn. When is the sum greater than 2000? You want to know the least number of terms. So you want to know the smallest value of n. And you want to find minimum n required. Okay, so that's the inequality you're trying to solve, and you want to find the smallest value of n for which this inequality is true. Find the least number of terms. Okay, so I think in the book they have equals all over the place. I don't like what they've done in the book, so I'm going to do it the good way. So first of all, a is 2. No, it's not. A is the first term. A is 4. It's going up by 5. Is 5. Okay, that's all you know. So Sn is n over 2, 2a plus n minus 1d. So more than 2000. So I substitute the values that I do know. N I don't know. That's what I'm trying to find. 2a is going to be 2 times 4 plus n minus 1 multiplied by d. And that has to be greater than 2000. So this is going to be an inequality in n. Okay, simplify it very carefully. Over 2. So the brackets will become 8 plus 5n minus 5 greater than 2000. I'm going to move the 2 to the other side and multiply the n into the bracket. So that will give me 8n plus 5n squared minus 5n. Take the 2 to the other side to get 4000. So I'm going to move it all to one side. 5n squared plus 3n minus 4,000 is greater than 0. So that is a quadratic inequality. Okay, to solve a quadratic inequality, you need to find the roots, first of all. So to find the roots, you can either use the calculator or you can use the formula. So if you use the formula, you would solve minus 3 plus or minus square root of b squared minus 4 times by a times by c all over 2a. That will give you 27.985 as one root. The other root will be minus 28.58 something. Okay, when you solve a quadratic inequality, you consider the sketch and you locate the roots. Okay, the shape is positive quadratic. So minus 28.58 is over here. The other root is 27.985. The inequality is greater than 0, which means you need to think about the region on the graph which is above x-axis. It's above the x-axis on this side and also on this side. Okay, so the solutions to the inequality then will be n less than minus 28.58. And this is not possible because n has to be positive for a start. So this can't be true. N has to be a positive integer anyway. On the other side, n greater than 27.985. So remember, you're trying to find the minimum value of n, the least number of terms required. Okay, so the smallest positive number that satisfies that inequality will be 28. So your conclusion is that 28 terms are needed for the sum to be greater than 2,000. Okay, so even if that number was 27.2, you would always have to round up to 28 terms.